Now we can move on to constructing a 1 minus alpha times 100% confidence interval for the difference between two population proportions. Again, the criteria has to be independent and random, be normally distributed, and the sample values are independent of each other, so independence, just like the criteria for a hypothesis test. The calculator command that you're going to be using to find confidence interval for two population proportions is number 15. So let's look at an example. The Gallup organization surveyed 1,100 adult Americans on May 6th to the 9th, 2002, and conducted an independent survey of 1,100 adult Americans on May 3rd through the 7th, 2017. In both surveys, Gallup asked the following. Right now, do you think the state of moral values in the country as a whole is getting better or getting worse? On May 3rd through the 7th, 2017, 846 of the 1,100 surveyed responded that the state of moral values is getting worse. On May 6th to the 9th, 2002, 737 of the 1,100 surveyed responded that the state of moral values is getting worse. Construct and interpret a 90% confidence interval for the difference between the two population proportions. P sub 2017 minus P sub 2002. So let's first look at this again. Is this quantitative or qualitative data? This is qualitative. Again, we're looking at proportions. Right? Our response is it getting worse or not? So we have a qualitative data there. Independent or dependent? Our moral values and what we think is going to be independent from these two samples, right? And notice that we have two different dates, so that's two populations. So if you follow this on your overview sheet, go to qualitative, right hand side, two population proportions that are independent. So we'd be working right here again. So it was an independent survey. That's another way you can find it. And we can assume it was random. So random and independent. Again, we need to verify. Let's look at the first population. So this is P sub 1, this is P sub 2. So 2017 numbers. Our sample size is 1,100. Proportion is 846 of 1,100. When you do that, we get about 195. So that is normally distributed. And then we take this for the second population to see if it's normally distributed. So 2002 data. Again, 1,100 is our sample size. When you do that on your calculator, you should get about 243. That's greater than or equal to 10. And then we need to check that each sample is 5% of the population or less. That is true, so the sample sizes are each no more than 5% of the population sizes. We've verified the criteria. Now we can move on to the calculator command. So our number 15 here. Stat test option B. X sub 1 again goes with P sub 1, which is the first one here, 2017. if you weren't sure, you could go back up here. P sub 1 is the first one, and then P sub 2 is the second. So 2017 data is going to go in for P X sub 1 and N sub 1. So 846 over 1100, and then 737 1100 at the 90% confidence interval. We get a lower bound of 0.068 and an upper bound of 0.130. And then let's interpret this. We are 90% confident that the difference between the proportion of adult Americans who believed that the state of moral values in the country as a whole was getting worse from 2002 to 2017 is between 0.068 and 0.130. Because this interval does not contain 0, we might conclude that a higher proportion of the country believed that the state of moral values was getting worse in the United States in 2017 than in 2002. So the 0 in a confidence interval means no significant difference. Because a difference of 0, right? We're looking at the differences. A difference of 0 means no significant difference because there is no change if the difference is 0 between the 2 years. So this hopefully makes sense to you.